Hello and welcome to this poster presentation. My name is Ruben and I'm a research student from Barcelona Supercomputing Center. Today, I will talk about device managing in ARM's runtime. So, what's one of the main concerns when working with devices? Well, each device can have a custom driver to interface with and its own memory address space. This is very bad for programmability, since having multiple different interfaces and having to manage different address spaces can be very difficult. And while there are hardware approaches that try to solve this problem, they may require specific hardware support, which is not ever possible, and usually they rely on page-based mechanisms that may have performance degradation due to fault sharing. As a research goal, we want to answer the question of if a software implementation can compare in performance to these hardware layers. And this new software implementation is the directory, implemented inside ARM's runtime, which replaces these hardware capabilities and provides new ones. Also, we provide a new common execution interface called the stream. This unifies the execution model of any device. Here in this image, we can see how there is a task that needs to be run and has a device associated to it. We forward that device and the dependency data to the directory, which will make the allocations and prepare the memory transfers as needed, ensuring in the process that the target device has a valid copy of the data. The directory will decide which is the faster path to transfer the data, if device to device or using host memory as a bridge. Note that since the directory works over regions and we manage the memory explicitly, we have no fault sharing on the device as we could in a page-based approach. Here we have two benchmarks of a matrix multiplication, one with FPGA and the other one with GPU. On the FPGA one, we implemented 3 accelerators of a fully fixed block size, and to measure the performance, we changed the matrix size. In red, we are using ARM's runtime, and in blue, we are using ARM's true runtime. As we can see, the performance is pretty similar, and our implementation supports branch dependencies, which ARM's implementation didn't. On the GPU benchmark, we are comparing the performance with different block sizes and a fixed matrix, all of this within ARM's true runtime. In blue, we use our implementation. In red, unified memory with data prefetching, and in yellow, unified memory without prefetching. As we can see, the directory, being case of our implementation, outperforms the hardware-assisted unified memory, and all of this while still being transparent to the user, thanks to ARM's true programming model. So as a final conclusion, a software approach can be faster than a hardware approach for some cases. It allows different devices with no direct communication with them to transfer data transparently to the user. And the developer framework makes adding new devices into ARM's true runtime easier, so we'll be able to support more devices faster. I would like to thank the Legato project and to the Comisión Interministerial de Ciencia y Tecnología for its fundings, and to Child's University Program for its software support and board donations. Thank you very much.